According to this figure, children, resolve the vector, that is, it is theta, it is the perpendicular, it is the base, that is cos theta, it is the sin theta, and it is the hypotenuse. So cos theta equal to base upon hypotenuse and sin theta is equal to perpendicular upon hypotenuse. According to this resolution vector are applied in this magnetic field. Children, here it is the perpendicular, it is the base, it is theta and b sin theta and b cos theta. Theta represent same, that is corresponding angle, and axis of the loop is here, which represent theta by the help of magnetic field. Children, we know that according to this formula, F1 and F2 vector is equal to 90 degree by the help of Fleming left hand and right hand palm rule number 2. Okay children, so we know that formula of F equal to F1 F2 equal to IBL sin theta, right? F1 F2 equal to IBL sin theta, F1 equal to F1 and F2 equal to IBL sin theta. Children, if theta F1 is equal to IBL sin theta and here theta is equal to 90 degree, that is IBL sin 90 1. Children, F2 is equal to same formula, F2 equal to IBL sin theta, that is theta, if theta is equal to 90 degree, that is children, next F2 equal to IBL sin theta, IBL sin 90, that is sin 90 equal to IBL. Therefore, both value are equal. Therefore, F1 equal to F2 is equal to IBL. Children, F1 equal to F2 equal to IBL. Okay children. Next, we know that by the help of torque, at any instant, the axis of the loop, normal n and dash drawn on the plane of the loop makes an angle theta with direction of field B vector. Then the magnitude of the instantaneous moment of the deflecting couple or the torque acting on the loop is given by torque equal to F force into perpendicular distance. Torque is defined as product of force and perpendicular distance. Torque is equal to force F1 F2 into perpendicular distance, that is force is equal to IBL. It is taken from F1 F2 here, F1 F2 is equal to IBL. Okay, IBL and B sin theta from this figure, IBL B, small b sin theta in this figure. Okay, so on putting the value of F1 F2 and B sin theta in this equation, that is IBL into small b sin theta. Listen children, we know that the formula of area, that is length into breadth, is equal to A. The area of the loop, torque is equal to IAB sin theta. Children, IBA sin theta, that is ILB. LB means area and B sin theta. It is the formula of torque, right? If theta equal to 90 degree, then torque is equal to IAB sin 90. Sin 90, that is 1. IAB into 1, that is torque equal to IAB. Children, second, torque is equal to IAB if theta is equal to 0. If theta equal to 0, that is magnetic line is parallel to the force. Therefore, theta equal to 0. So then torque equal to 0. If children, if theta equal to 180, then torque is equal to also 0, right? Similarly, again and again we find out the value of torque. Therefore, the force F3 and F4 acting on the remaining two sides P, Q, R and SP of the loop are equal and opposite to each other, but their line of action is the same, hence they are cancelled each other, do not form a couple. Thus the net force on the current loop is 0. Children, here F3 and F4 value will be 0 because theta equal to parallel to the magnetic field, therefore theta equal to 0. Okay children? Listen children, if I will consider n loop, then number of loops are putting in this torque. The expression torque IAB sin theta is true for any planar loop of the area A in a uniform magnetic field with which is normal make an angle theta. Children, if in the place of a single current loop we take a coil or solenoid mode of the current of loops, then the torque IAB sin theta will act on each the loop. The torque on the whole coil is thus given by torque equal to NIAB sin theta, where tau is the torque. It is represented the torque, and n is the number of loops, and I is the current, A is the area of the rectangle, of the coil, of the circle, of etc. B is the magnetic field, theta is the angle. Okay children, so torque in vector form, the current carrying coil is equivalent to a magnetic dipole. As such, the torque on the coil in the magnetic field can be expressed in the terms of magnetic dipole. Therefore, torque is equal to NIAB sin theta. Then the term NIAB is defined as the product of the dipole moment and SI unit of ampere meter square. Children, it is the representation of vector form, very important. It is the vector form, 2 marks. Torque vector equal to M vector cross B vector, where torque tau is the torque, M is the magnetic line moment, and B vector is the magnetic field. Children, so it is the formula of cross product. It is the formula of cross product. We know that the formula of the cross product, A vector cross B vector, A vector cross B vector is equal to, that is AB sin theta, AB sin theta. Children, AB sin theta. If dot product is that, so AB cos theta, A vector dot B vector is equal to AB cos theta. A vector and B vector is the vector form, AB are magnitude, theta is the direction. Okay children? In hydrogen atom, the electron orbiting around the nucleus is also current loop and has a dipole magnetic moment of about 9.3 into 10 power minus 24 ampere meters. Okay children? Good day.